Hello. In this video, we're going to work on a number of problems that comprise some of the key pieces of information, key learnings, key skills that you've learned in algebra this year. So these are questions that may appear on an algebra final. They may appear on a challenge test that you need to, that you may receive that demonstrates mastery of algebra so that you can pass into geometry here in California. This is specifically designed for some students in my current class that want to pass into geometry and demonstrate mastery of algebra. This is going to be a two-part or more than two-part video. In this video, I specifically will solve 6 problem types that are kind of towards the beginning of an algebra curriculum, and all algebra students should be able to demonstrate mastery of these problems. As I show them to you, what I'd like you to do is to work the problems and then to see the answer. Don't just watch me work the problems. You'll get a false sense of security, a false sense of knowing how to do these problems. So I encourage you to work these problems on your own. They're all multiple choice problems. I encourage you to actually work them without trying to look at the answers. Try and solve them, get the answer, and then verify that your answer matches one of the 5 that are given. With that said, let's move on to working these 6 problems. Okay, so these are, this first problem, we'll notice is a distributive problem, and even the second one, I'll give you the hint right now, is a problem in distribution. So try to solve these 2 problems, and then I'll come back and work them. So pause the video, give these problems a go, and see what you come up with. Okay. So now I'll assume that you've tried this first one. Let's just copy it over right here. Number 1, -4 times. Let me move it down just a tad. -4 times 1/2 x minus 3y. And this is a problem, again, in distribution. So I like to teach my students to draw arrows between the term on the outside and the number of terms on the inside. And here we have 2 terms on the inside. So we're going to have 2 multiplication problems. And so we're going to get -4 times 1/2 x. In this second case, what I like to do is I usually like to look at what type of numbers I have, negatives and positives, and figure out what my sign is going to be. So here I have a negative multiplied by a -3y, if you will. So my answer is going to be positive. You can also look at this as a -4 times a 3y, in which case it'd be -4 times 3y, but you're going to be subtracting that answer. And so this negative is going to come into play. One way or the other. If you look at this as a -4 minus a -4 times 3y, you're still going to end up with a -4. Sorry, let me start this all over again. If I look at this as a -4, as if I'm subtracting. Right, so let's see. Let's look at our terms. So kind of ignore what I just said. If I look at this as a -4 times a 3y, I can look at it as -4 is subtracting my -4 times my 3y, and I'm going to get a -12y, which equals 12y. But I like to just solve it kind of all at once. And so what I like to teach my students to do is to look at this as a -4 kind of times a -3y. So if I do that, I look at my -4 times a -3y, and I end up with a positive 12y, which is what I got below. So I just like to get that sign right there, positive. Negative times a negative is going to be a positive. So now I have my 4 times my 3y. I don't know if that made sense. I kind of went over that kind of fast, and I don't know if I explained it that well, but the key thing is a negative times a negative is going to be a positive. And in the first case, we have a negative times a positive. So here we're going to get a negative. There's our negative sign. So now we can multiply our two terms, and we get our second term is positive 12y. Our first is a negative 4 times a half. Well, we can cross cancel, and we get negative 2x. So there's our negative 2x plus 12y, answer D. Okay, let's move on to number 2. And there's a lot of ways to look at this, but notice it comes with distribution, so that kind of gives you the hint. If you're pretty savvy with number theory or you know, number, you have good number sense, you can actually think of, you know, this 121 as being broken up as 100 plus 20 plus 1. And if you have that insight, you have 65 times 100 plus 20 plus 1. If you have that insight, you can immediately see the answer when you apply distribution. So I'm going to give you these arrows like this, and I'm going to let you pause one more time. So now I'm going to ask you to pause the video, pause, and ask if you can, you know, now try to solve it. Okay, now I'm going to assume you came back. Now, if you look at this as a distribution problem, after you've divided, you know, broken out 100 as 100 plus 20 plus 1, which is the definition of 121, you get 65 times 100 plus 65 times 20 plus 60 times 1. Does that look like, you know, does that look like anything above? And the answer is yes. It looks exactly like, whoops, 65. Gosh, how many mistakes can I make in this video here? 65 times 1. And so we get A. It does, looks exactly like this. And you can see after you've broken it out like this that B cannot be the right answer, because if I would have, you can, you know, once you know how to break up 121 like this, you could say, well, that second one, they're just trying to break it up into 120 plus 1. This is answer B, and that's 65 times 120 plus 65 times 1. Well, this one is 65 times 120 minus 65 times 1, so that can't be right. You know, the second one is, well, same difference, 65 times 100. Whoops. Well, this would be 65 times 100 plus 21 is another way to break it up, and that looks kind of like this, except for this answer is 65 times 100 plus 65 times 21. Well, there's our 65 times 100. Well, negative 21 does not equal that, so that can't be right. Similarly, you can do the same thing and see quickly that E isn't right, because you need to be adding 65 times 21, not just 21. And then if you multiply 65 times 121, you're going to see that it doesn't equal that. So our answer is A. So let's just you know, take a little victory here, give us you know, 2 happy cats, and we're going to move on now to number 3 and number 4. Hopefully, I apologize. You know, I'm sorry for that long answer. We'll do a better job on number 3 and number 4. All right, let's open number 3 and number 4. So here we go. We're going to try and solve a basic equation. These ones, you should know how to solve these. You know, we're just solving for x. And it's interesting here. It says solve the equation, right? You just assume, it doesn't say x equals down here on the bottom, but you need to know that solving an equation, and when you have a single variable, means you're trying to get this thing down to a place where x or y or n equals a certain number. All right, so let's make sure you've tried number 3 and then try number 4. And then pause the video. Pause and try. Don't just sit here and watch me do it. You're going to get a false sense of security. Okay, let's move on to solving these problems. I'm assuming that you have all the right answer. You've identified the right answer, and you're just going to watch me solve it. So let's go 2 times x minus 4 equals 13 minus x. Well, we got this distribution problem here, so let's distribute this, and then everything should start to come into crystal clear focus. We're going to combine our x's on the left and combine our constant terms on the right. Three x on the left, 21 on the right. And then we get x equals 7. Box our answer and come back over here, c equals 7. And then we can also check our answer if we want to be diligent about this. And we could say, well, if we plug back a 7 in as our x and our 7 as our x, we get 7 minus 4 is 3 times 2 is 6. So we get 2 times 7 minus 4 on the left, and on the right we get 13 minus 7. And this is 6, and that's 6. So good. All right. Now, this next problem is one in which we are trying to rewrite the formula in terms of b. That's just another, it's kind of like saying solve for b. It's like get the b on one side and get everything else on the other side. So the way to do that, we want to get this guy, get rid of this guy, and get rid of this guy. So how do we do that? Well, let's do it in 2 steps. Let's try and get rid of that half. So the way we get rid of a half is we can take this whole term and multiply it by 2, 2 over 1, and take the left side and multiply it by 2. If we multiply one side by 2, we have to multiply the other side by 2. So now we get 2a equals, this half cancels with this 1, equals bh. And now we're almost there. There's our b that we're solving for. So to get that b by itself, we have to multiply both sides by 1 over h, or divide by h, however you like to think about it. Multiplying by 1 over h and dividing by h is the same thing. So on the left, we get 2a over h, and on the right, we get b. So let's use the reflexive property and write it like this. And there's our answer, and the answer is C. Good. Okay, just the key point here is that all of the operations that we can apply to either side of an equality, whether or not we just have a single variable or lots of variables, we can just do the same thing. We can divide both sides by, we can multiply both sides by a number, we can divide both sides by a number, we can add and subtract both sides by the same number. And everything works out nicely, and it's legal. Okay, let's open up our last 2 problems before we move on to, before we complete this video. And let's see. So now we have, this is an interesting problem. This makes sure that you understand another type of equality, another type of, another property of fractions, a property when you compare 2 fractions to each other and you declare that they're the same, there is an operation that you can do, and it's called cross multiplication. So I'd like you to try this like the other problems. Try, pause video. Pause video and try. Okay. Okay, assume you're back. Now to cross multiply, we're going to create an equality by multiplying both sides, top and bottom. So I'm going to multiply the denominator of the left times the numerator on the right, and I'm going to get 3x. And I'm going to multiply the numerator on the denominator on the left times the numerator on the left. So my 2 times 2x minus 5. Now realize I'm multiplying by the entire thing And to do that, I need to use these parentheses. Okay, now I need to do my distribution. And I get 4x minus 10 equals 3x. Now I'm going to, let's see, if I subtract 3x from both sides, it'll really nicely leave me with an x here. So I'm going to do that. And I'm going to add 10 to both sides to get my constant term on the other side. So I got 10 minus 3x and negative 3x plus 10, which are equivalents, right? I added, this is just adding 10. So we get 10, these cancel, equals x. Cool. Using the reflexive property, x equals 10. And we can check our answer. 2 times 10 minus 5 is 15 over 3. Does that equal 10 over 2? Well, yes, 5 equals 5. Boom, happy cat. Ooh, scrunchy happy cat. Wide happy cat. Tall, skinny, happy. We'll go with tall, skinny, happy cat. Okay. Whoa. All right. We're going to finish up here with number 6. I want you to try this. These are inequalities, and they work almost the exact same way as equalities. On this problem, however, you're going to see one rule, and I'm going to give you a hint before you try it. Maybe you've already tried it, but you know, when multiplying or dividing an inequality by negative number, flip the inequality sign or inequality operator. That's my hint to you. So now, you know, pause and solve. Pause and solve. Your turn. Okay, assume you're back now. So let's do what we know how to do. The left side's just an expression. We're going to distribute 4x minus 6. 2 times 2x is, you know, 2 times 2x minus 2 times 3, right? And that's less than or equal to 7x plus 9. Now let's get our x's on the left. So we're going to subtract 7x, subtract 7x, and we're going to add 6 to both sides, add 6. So these cancel. I get negative 3x is less than or equal to 15. Now here's where this rule is going to come into play. Right? So I'm going to divide by negative 3 and divide by negative 3. And when I do that, I'm going to have to flip this guy. So now I go x is greater than or equal to. When we flip a less than or equal to, it becomes a greater than or equal to. 15 divided by negative 3 is negative 5. And we get x is greater than or equal to negative 5. Okay, good. Happy cat. Skinny happy cat. Dizzy happy cat. Okay. We are done here. We're going to pause this guy, or we're going to end this guy right now. And we're going to end this guy, and then we're going to start. I'm going to show you the other set of problems. There's 7 more problems in this set. We're going to do those next, and I'll post those in a second update, or a follow-on, a sequel, if you will. And there may be another sequel, depending on how good these are. You know, if they start making millions of dollars, I might have to do 5 sequels. We'll see. All right. Thank you.